Welcome back everyone to another LDC Media video. As of now, we have over 20 videos that cover deep astronomy topics such as rogue planets, the multiverse, and the search for extraterrestrial life. However, for this video, we thought it would be nice to bring it back to Earth, our home. In today's video, we will be covering Earth's atmosphere. Specifically, we'll be talking about the different orbits, aka layers, astronomical tools currently in our orbit, and how to get things into orbit. First off, it is important to know that Earth's atmosphere is made up of approximately 78% nitrogen, 21% oxygen, and around 1% trace gases such as argon. The importance of oxygen is obvious. It sustains our bodily functions and keeps us alive, and is also a key element in water and the evaporation process. However, why is nitrogen important? Nitrogen is also necessary for life. Both our DNA and RNA proteins require nitrogen to support nucleic acids. Without a high nitrogen content in our atmosphere, life would not be able to evolve or even exist. There are 5 different orbital layers, each of which has its own sublayers. Starting from the bottom is the troposphere. This is where you find things like clouds and plains. Next is the stratosphere. This is where the ozone is and the area which high-flying fighter jets occupy. Next is the mesosphere. This is where meteors are burned up. If it weren't for the mesosphere, our planet would have been annihilated hundreds of millions of years ago due to meteor collisions. Next is the thermosphere. This orbital layer holds the Kármán line and is often where one would find free-falling satellites. This is a phenomenon where satellites are not actually orbiting our planet because they lack the necessary velocity. Rather, they are falling towards Earth. But since they have enough velocity to keep moving forward, they end up falling around the Earth continuously. This is a very important concept in aerospace engineering as it cuts down both production and launch costs. Finally, the exosphere. This is where many high-flying satellites exist, and it is also the area with the least pressure. It is key to note that as we move up in the atmosphere, pressure decreases. This is because pressure equals the force applied over a given area. Although the given area does not change, the amount of force coming at you from above decreases as you go up, and therefore pressure decreases. Next, we'll go over the hundreds of astronomical tools in our orbit currently. You'll be surprised at how many there are. As of April 2020, there are nearly 3,000 operational satellites in existence. During the Cold War, there were also thousands of satellites as the US and the USSR engaged in espionage. The Soviet Union, despite its broken communist economic system and curtailment of basic human freedoms, had an amazing aerospace industry. They launched the first satellite into space in 1957 called Sputnik, which was an extremely unique and sci-fi looking satellite. A notable astronomical tool currently in our orbit is the International Space Station. Most people don't realize it's actually within Earth's orbit. The International Space Station and its surrounding area is a place for astronauts and scientists to do research and develop future space programs. Astronauts go up to the space station for usually 6 months with a mission, like, for example, adding a new lens to the Hubble telescope or recording plant life on the space station itself. One of the biggest problems with modern-day space travel is how tough it is to get something into orbit. It's even way tougher to get something out of orbit. Escape velocity, aka the velocity an object needs to leave the Earth's pull, is shown through a mathematical equation. The square root of the gravitational constant multiplied by the mass of the object trying to escape multiplied by 2. Divided then by the distance from the center of the mass. As you can see, the greater the gravitational constant and mass, the greater the necessary escape velocity. The farther away something is from the center of mass, the harder it is for something to escape the Earth's orbit. No worries if you do not fully understand the numerical relationships described within this formula. The only qualitative understanding necessary is that it takes tons and tons of fuel to get a respective escape velocity. Governments and private space companies alike spend millions, sometimes billions of dollars buying, developing, and researching cost-effective fuels. Well, that does it for this video. We hope you learned about the Earth's atmosphere, orbital layers, some astronomical tools, and what it takes to get into outer space. If you enjoyed it, please tell your friends and hit the like and subscribe buttons. See you next time. Thanks.